Okay, combustion reactions. We talked about combustion a little bit. Combustion reactions are characterized by something reacting with oxygen, and these are going to produce one or more oxygen-containing compounds, because if it's reacting with oxygen, oxygen has to show up in the product somehow. A lot of times, water is one of the productions. One of the products, I guess it's a production. Combustion reactions also emit heat. We should know that intuitively, right? When you burn something, does it get hot or cold? It gets hot, right? So if our reactant contains carbon, hydrogen, and possibly oxygen, the products are always the same. So if we have carbon, hydrogen, oxygen, we always get carbon dioxide and water. That's something you need to remember. So here's an example of the combustion of natural gas. CH4 reacting with oxygen forms carbon dioxide and water. Every time. This has carbon and hydrogen in it. If it has carbon, hydrogen, and oxygen, we'll also get CO2 and H2O. If it's something else, I won't ask you to predict the products. So write a balanced equation for the complete combustion of liquid C2H5OH. Well, this is what's combusting. So I'll start out with that, C2H5OH. This OH group tells me it's an alcohol. And the question tells me that's a liquid. It doesn't give me anything else. Combustion requires what? Oxygen. So the other reactant is always oxygen. My reactant here is carbon, hydrogen, and oxygen. What are the products? CO2 and water. The CO2 is a gas. Carbon dioxide is a gas. The H2O is also a gas. Because when you burn this, it's hot. And at high temperatures, water is a gas. If you find it disturbing that burning something produces water, and yet we use water to put out fires, if you have a gas stove or a gas grill, or I suppose you could do it even with something like a candle, you have an open flame and you put, say, a pot with cold water and you just hold it above, what you'll see is condensation appear on the bottom of the pot. Where did that come from? It came from the combustion. As the water produced hits the cold surface, it condenses. And so as we're burning things, we're actually giving off water. That's something that's just not at all obvious. Now we need to balance this thing. Combustion reactions sometimes get a little messy, and so these are the ones I tend to use that tally method on. Should we throw caution to the wind and just go for it? Yeah, why not? I can't remember if this is a bad one or not. Let's just start at the beginning. I've got 2 carbons, and over here I have 1. So I'll put a 2 here. So I have 2 carbons. Here I've got oxygen by itself. I don't want to mess with it. I want to leave that one to the end. So I want to do hydrogens next. How many hydrogens are on the left side of the arrow? 6. They're in 2 different places. It's okay. There's 6 of them. And so over here, how do I make 6 hydrogens? Put a 3 in front, right? And now we'll cross our fingers and hope that the oxygens are going to work out okay. Over here I have 1 and 2. I've got a total of 3. And over here I have 4 oxygens in that one and 3 oxygens in this one, right? 4 plus 3 is a total of 7. So I need to get 7 over here. I don't want to mess with this one because that I'd have to change the hydrogens and carbons, and I already got those all fixed up. So yeah, if I change the oxygen to a 3, that'll give me 6 oxygens here and 1 over there, which is also 7. So this one ended up not being very messy. Any questions? Alkali metal reactions. Alkali metals react very vigorously with nonmetals. They react with the halogens. Remember, the halogens are group 7A, fluorine, chlorine, bromine. In this general form where two metal atoms will react with one halogen molecule and make an ionic compound. A specific example here is sodium reacting with chlorine to form sodium chloride. And there's a picture of that. There's a lot of heat and sparks, and it's a very vigorous reaction. The smaller alkali metals are more reactive as you go down. They get, the top ones are reactive, but reactivity increases as you get down to the bigger ones. Alkali metals also react with water. So the metal will react with water, and what we get is a metal hydroxide and hydrogen gas. These are also very vigorous reactions. They're highly exothermic, and they can be explosive because the heat that's generated can ignite the hydrogen gas. So here we see lithium is fizzing, that's the hydrogen gas forming. Sodium in small quantities will give you a nice reaction. You've probably seen those YouTube videos where they throw a chunk of sodium into their swimming pool.
So the water can be cold when these reactions with salt occur?
Yep, these will happen with cold water. And potassium is even more reactive. Here we've got sparks and stuff shooting out.
So cesium would be lower.
Yeah, cesium would be really bad with water. So we don't find the alkali metals as elements in nature because there's water all over the place, right? If you had a piece of sodium metal and just had it sitting on, in a beaker open to the air, it would react with the water in the air. The only way you can keep these is either by blanketing them with, say, a noble gas, or keeping them submerged in oil to keep the water away from them. So they just react. So halogens react with many metals. We just saw how they react with the alkali metals. They can react with other metals as well, and the exact ratio of them would depend on what charge that metal ion takes. We also see that hydrogen reacts with the halogens to make hydrogen halides. These are molecular compounds, but when they're dissolved in water, they are acids. You can also form compounds between the different halogens. So here are three tubes containing elemental. Here's iodine, chlorine, and bromine. The iodine, we used this the other day. We didn't see any purple gases because we weren't heating it up. But it does react with lots of things and make messes. Chlorine is a gas at room temperature, and that's pretty toxic. Bromine is a liquid at room temperature, and its gas is brown. It's kind of interesting. So write a balanced chemical equation for each reaction. The reaction between aluminum metal and chlorine gas. Questions like this, I think, are pretty challenging for Chem 1A. And it's not just some formula that you follow. You kind of have to think about it. This one should be doable. So aluminum metal, that's going to be aluminum. Metal, it's a solid. It's going to react with chlorine gas. Chlorine is a diatomic element. We're told it's a gas. The other way we can tell it's a gas is that the symbol for chlorine on this periodic table is red, and all the red ones are gases at room temperature. So when these react, they're going to form a compound between aluminum and chlorine. And what kind of a compound would that be with a metal and a nonmetal? It's going to be ionic. So what we're going to do is we're going to think about, well, what ions do these guys form? What's the charge on an aluminum ion? +3. We know that because it's in group 3A. And the charge on a chloride ion is -1, because it's 1 to the left of the noble gases. So from the charges, we can tell how they're going to go together. We're going to have Al, Cl3. We need 3 chlorines to make a neutral compound. Is that going to be a solid, a liquid, or a gas? How are we supposed to know? It's going to be a solid. Ionic compounds tend to have very high melting points. So probably the most familiar ionic compound is table salt, sodium chloride. Does that melt? You can melt it, but not in your kitchen. It melts at an extremely high temperature. Most ionic compounds are going to be solids at room temperature. So then how do we balance this?
So, what numbers do we need?
Yeah.
2 aluminum. Well, we need, because we're going to need 3 chlorine gas,
Mm-hmm.
we're going to need 2 aluminum chloride, trichloride, whatever.
Right, so we're going to need 2 of these so that we get 6 chlorines, and then we can get 6 over here with a 3, and then 2 ALs. Because this is an even number, and that's an odd number, and if I double this one, I make it into an even number, and then things get better. The reaction between lithium metal and liquid water. So lithium metal and liquid water. If this is a homework problem, what I would expect you to do is go look it up. What do alkali metals do with water? Well, they make metal ions and hydroxide ions and hydrogen gas. So here our metal is lithium. So that's going to be Li+, and it makes hydroxide ions because they told us, oops, I'm going to do that. And it makes hydrogen gas. These ions, those are going to be aqueous. Again, that's not super obvious either. But this metal is reacting with liquid water. This is happening in water, and so those ions will be dissolved. I would never ask you a question like this on an exam. How do I balance this?
Another H2O. And another hydroxide ion.
Yep. Because we had 3 hydrogens over here and 2 over there, so we need more hydrogens over here. So we'll put 2 in there, and you get 4, and we've got 3 over here, but 2, and then we could double this one and get 4 hydrogens. And now we've got 2 oxygens and 2 oxygens and 1 lithium. That's a hard one.
So when a metal reacts with the water, it always produces a metal plus hydroxide plus H2?
The alkali metals do, yes. Yep. The reaction between gaseous hydrogen and liquid bromine. So H2 gas and bromine liquid. It's H2 and Br2 because those are both members of that group of 7 diatomic elements. What are these going to form? Well, have we seen anything that's got hydrogen and bromine in it together? Does that make you think of an acid, maybe? Hydrobromic acid? So this is not forming an acid here, but we can use the idea of the acid to figure out what its formula is. Hydrogen forms a +1 ion. Bromine forms a -1 ion. And so this is going to be HBr. That's going to be a gas. I wouldn't expect you to know that. If this is dissolved in water, it forms these ions and is called hydrobromic acid. How do I balance this? I just need a 2 here. Any questions?